ionic radii or the trends in the ionic radii. The ionic radii are difficult to measure accurately. Definitely, the giving up of electron is different. Whenever they are giving up electron or they are taking electron, we cannot predict the exact location or boundary of an orbit, because we are well aware that orbit is a word simply designed to define the term that orbit is the one where electrons could be found anywhere, because orbits are the point where there is a probability of finding electron anywhere. Likewise, we can say that they vary according to the environment of the ion. Definitely, when there is a cation, it will donate electron. It will be surrounding up. It could be present everywhere surrounding, or up to even the limit is unpredictable. But when it comes to an anion, we can make a general prediction that anion should be smaller in their sizes. Their orbits are even smaller. Why? Because they keep on attracting electron. The nucleus will be attracting electrons. That is why their circumference or their diameter is quite smaller as compared to the diameter of a cation. For example, it is important how many opposite charges are touching each other, such as the coordinate number. The nature of ion is also important, like either they are highly polar, either they lack polarity. That also matters a lot. There are several different ways of measuring ionic radii, and they all produce slightly different values. If you are going to make a reliable comparison using ionic radii, all the values must come from the same source. Definitely, if you are going to take them and you are taking measurements, so you should be making one point as the base. Likewise, we can simply say that if we are measuring we are having some large uncertainties while using ionic radii, trying to explain things in the detail. Okay, basically we are well aware that when it comes to group number 1, elements of group number 1 are the donor of electron, and we know that they belong to group number 1. Group number 1 is when electrons who are really reactive metallic group, they love to donate the electron. Okay, if you look up to their electronic configuration, this is lithium. Lithium is having 2 electrons in its outermost shell, and they will engage that lithium for the in the furnace shell. They will engage that lithium for the donation of electron. Likewise, the ionic increases down a group in the periodic table due to the following reasons. Reason number 1 could be that there are addition of energy levels as we go down. The new energy new energy levels or shells are added down the group. When new shells are added, they increase the distance between nucleus and the outermost electron. Due to that thing, addition of energy levels will lead to increase in the ionic sizes, as well as increase in shielding effect. The number of inner electron increases. Shielding effect for the outermost electron will also increase. So the between electrons or the middle electrons will be reducing the attraction of nucleus for the outermost electron. Also, decrease in the effective nuclear charge. The nuclear charge remains constant, but the increased distance between the nucleus and the outermost electron is also affected by this influence. The key points are that increase in the ionic sizes happens down the group, atomic radius increases due to additional energy levels, shielding effect reduces nuclear charge. As we go from the left hand side of the table to the right hand side of the table, the nuclear charge increases, nucleus, the electronegativity increases. We are deviating from being highly metallic group to the non-metallic group. The electronegativity increases that led to cause attraction, a strong attraction of the nucleus for the outermost electron. Due to that massive attraction, there is a strong the size of the atomic radius decreases. Likewise, when it refers to the group number 7, its reactivity decreases down the group. Simply, fluorine is the most electronegative element of the periodic table, and it also have ability to attract the any electron present nearby it. Also, because its outermost, due to its strong ability to attract the electrons, its size is very small, and it's the case when all the group is a non-metallic group. But when we move from top to bottom in the fluorine, from the fluorine to iodine, The reactivity although decreases down the group, but the atomic size increases down the group. It's easier to gain the electron for these non-metals down. When nucleus is attracting the electrons, they develop strong electrostatic forces of attraction between them. The stronger the forces are, the closer the nucleus and the valence electrons will be. And due to this strong attractive point of the electron towards the nucleus, the size will be getting smaller. So we can say that the more electronegative an element is, the smaller its size will be. The electronegative the element is, the smaller its size will be. So we can say that in all the periods when we move from top to bottom, the reactivity increase for the metals and the size of the cations is getting bigger because they keep on donating the electrons. When we move from uh, left hand side to the right hand side of the periodic table, the size it decreases, especially for the non-metals, because the more electrons they will attract, the more strong attractive force they will when develop. It comes to the period number 2 and period number 3, period number 2 refers to when we move from the left hand side to the right hand side, we are simply deviating from the very reactive metallic group to the non-reactive non-metallic groups, moving from nitrogen to oxygen and then to the fluorine. Although number of protons increase, although number of electron increases, but the electronic configuration remains almost same. Okay, basic electronic configuration is same. Okay, now ionic radii still decreases. Why is it decreasing there? Because we are moving from the metals to the non-metallic group, and we have studied that when we move from the metallic group to the non-metallic group, the reactivity decreases. Atoms or non-metals attract the electrons. When they are attracting electrons, they are moving to the they are moving from being reactive to the non-reactive state of them, and that is why the ionic radii decreases. Why? Because the more electrons they will accept, the more stronger attraction they will develop for the nucleus, and their size will be getting smaller. Then likewise, when it comes to the period number 3, when we move from sodium to magnesium to aluminium, we are moving from the left hand side, the very reactive metallic state, to the non-reactive metallic state. Is simply the basic configuration is almost same, but number of protons are increasing. It means that number of electrons are also increasing. Both of these things are directly proportional, or sorry, inversely proportional to the size of an atom. Whenever we are moving from the left hand side to the right hand side, the reactivity, although number of electron increases, number of protons increases, but the reactivity of element decreases. So the ionic radius over here will be decreasing, because due to increase in the number of shells and number of electrons, number of protons, and their ability to accept the electron increases, the ionic radius will be decreasing, because nucleus is attracting electrons more powerfully. When it is attracting them powerfully, the size will be decreasing. Also, in other words, we can say that they have the same number of electrons. Therefore, the same electronic configuration is observed. The ionic radius decreases as the number of protons and increases, because they will be increasing the attraction for the electrons. When the attraction of nucleus is increasing for the attraction of electrons towards the nucleus, the size of an element decreases. As the positive charge of the nucleus increases, the electrons are attracted more strongly and are therefore pulled closer to the nucleus. So the closer they are towards the nucleus, the nucleus will be attracting even them with the greater force, and that will lead to decrease in their reactivity, as well as there is a strong attraction of nucleus for the electron, especially particularly for the non-metals. For the non-metals, the greater the number of electrons they are carrying, the greater the attraction the elements will face. Polarization is simply the attraction between a positive charge and the negative charge. What require a thing to be a polarized is that it should carry some positive and negative charges. The opposite the charges are, the more polar they will be. Obviously, positive and negative are polar, but in sort of chemistry there is another tendency. We can say that the greater the difference in the electronegativities of the elements are, the polar they will be. We have seen that the bond between hydrogen and chlorine are polar, but they are making polar covalent bond. People usually confuse is that they confuse that, okay, they used to make ionic bonding. No, hydrogen and chloride bonds are making that, they used to make polar covalent bond. The bond got polar because of the huge difference in their electron negativities. The greater the difference in their electronegativities are, the polar they will be. Likewise, polarization and polarizing power of an ion, what is it about? They are stating in that in an ionic lattice, the positive ion will attract the electrons of the anion. Since positive and negative charges attract each other, if the electrons are pulled towards the cation, the anion is polarized. Since even distribution of its electron density has been distorted. It looks like two elements or two ions were attracting each other strongly. One is going to disturb the electron negativity of the other element. Since it refers to an anion, they are attracting the electrons of it will simply disturb its electronegativity. It will be trying to make every possible thing to attract electrons of a non-metal of a metal, sorry. Now there are two different factors. There are two different factors, two main factors, which are known as the Fajan's rules, and they are summarized as follow. Polarization will be increased by high charge and small size of a cation. When there is a small high charge and the element or the size of ion is really smaller, this is the high charge density of a cation. The smaller the size is, the greater the charge it will be carrying on to it. Why? Because in this condition, the metal or simply the cation is the one who had donated enough number of electron. When it had donated enough number of electron, it will be reactive enough to get polarized. Likewise, when it comes to a non-metal, it needs them, although they will be carrying a high charge, but for them to occupy a higher charge, they should have in a larger size. The larger they are, the higher the charge they will be carrying. Somebody could ask you, why is it possible that two ions are there, but they require both of them should carry a high charge, but simply concepts are different. One should be of the smaller size, another should be of the bigger size. We can simply answer the question is that when it comes to a cation, the cation's its nature is to donate the electron. The smaller a cation would be, the more chances will be that it had donated its electron. The more electron it had donated, the smaller it will be. And due to the difference in its sizes, due to its ability to donate the electron, it will be attaining the smallest size, so that we can stabilize it. And if we even add electrons to it, it will again donate its electron. That is what would justify the reactivity of the element. Likewise, we can say that when it comes to a non-metals, the non-metals are those non-metal, when they accept electron, they will attain something with a state which is called as an anion. The anions are those who have to accept the electron. When they have to accept the electron, when they are accepting the electron, they will keep on adding the electron. And when they are adding the electrons, when they keep on accepting the electron, their size will be greater. When they got bigger in their size, their reactivity will also decrease, but they will attain some high charge on them. High charge and small size of a cation, simply the ability of a cation to attract electrons from an anion towards itself is called as polarization. You can also state it the ability of highly electronegative element to attract highly electropositive element is called as polarization or polarizing power of an element or a cat or an ion basically. A cation with a high charge and small radius has a large polarizing power. An approximate value for the polarizing power of a cation can be obtained by calculating its charge density. The charge density of a cation is the charge divided by the surface area of an ion. Simply, the charge density is when you can take a charge, divide that charge up to the surface area of a cation. The smaller the value is, the reactive it will be. So simply, if the ion is assumed to be a sphere, the surface area is equals to 4 pi r square, while the ionic radius is given as follows. Simply, the approximate value is given by the sphere of an element of an ionic radius. So charge density is equal to charge divided by r square. So the smaller the value is, the reactive it will be. High charge and small size of an it should be high charge and large size of an anion. Simply, the ease with which an anion is polarized depends upon its charge and its size. The one with the bigger charge and small size are polarized most easily, because if we say that it is having small size, they will be attracting electron. Let us say an anion is small, let's say it's smaller, it means that it will be highly reactive. Why? Because it is attracting the electron, it is in a way, it is in search of electron, because it is unstable. So if we add electrons to it, it will readily accept it, because once it is its nature to accept electron. Likewise the anion will be in search of electron. What we can say is that when an anion is of the small size or it's of the large size, let's see both the probabilities. If an anion is of the small size, it means it refers to that an anion is of the smaller size and it is highly charged. Why? Because now it is in a state to in search of electron. It is unstable again. Why? Because it wants its outermost shell to be like its valence shell to got fulfilled. Just like we can add electrons to it, and that is why if its size is smaller, it will be readily reacting with the elements, with the substances, so that it can accept the electron from them and got stable. That is the probability for the small size of the anion. If we feel it is of the larger size, it is again reactive. Why? Because although if it got its outermost shell got almost filled up with the electron, but that is also important, because in that case its ionic size will be smaller. It will still have ability to attract the electrons. That is how we can justify both the statements. Now, the ease with which an anion is polarized, it depends upon the charge and its size. An anion with a charge, anion with a large charge and small charge size, they are polarized the most easily. In an ionic lattice, the polarization of the anions creates some degree of sharing of the electrons between two nuclei. So they will be attracting, one is ready to donate, other is ready to accept. That is how they can make a polar bond. The summary of this topic is that ionic radius, positive ions have a small radius than the parent atom, since they are losing their electrons. Also their shells. Negative ions are the anions, they are the electron attractors. That is why, since they keep on adding electrons to fulfill their outermost shells, the valency, the their ability to attract electron increases as we are moving ahead to the non-metals. That tends to increase in the outermost shell electrons. So outer shells will be adding. That will also lead to add the electron repulsion. So the positive ions will reduce their size as compared to their parent atoms, while negative ions or the anions will add their sizes. They will be getting bigger as compared to the parent electrons or parent atom. Atomic radii decreases from group 1 to group number 14 for the positive ions because they have to donate their electrons, but the effective nuclear charge also increases for them. Atomic radii decrease from the group number 14 to 17 for the negative ions since there is an increase in effective nuclear charge due to the presence of due to the increase in the electronegativity. But when it comes to their anions, they keep on adding electrons, so their anions will be bigger than that of their parent shell. The additional question is that which ion would have large ionic radii, either sodium or magnesium. So we can simply say that if we compare their basic configuration, they are moving from left hand side to the right hand side. It looks like the donation of electron increases. Magnesium can donate 2 electron and sodium can donate 1 electron. Likewise, when you move from the left hand side to the right hand side for the metallic group, the metallic character is going to be affected. Okay, but when we will refer to their protons, since everybody like sodium is donating one electron, and but there is an imbalance in electron and proton. But when we feel that the donation of magnesium is double as compared to the sodium, because sodium can donate 1 electron, so there are the one proton exceeds the number. But when it comes to the magnesium can donate 2 electrons, so there is an imbalance of 2 and 2 proton definitely. So 2 electrons are released, and that led to the donation of 2 electrons. So definitely we can say that it led to increase in the nuclear charge, because in case of sodium there is 1 proton to disturb the valency, but when it comes to magnesium there are 2 protons who are actually going to face attraction of the, you can say that they are attracting the imbalanced proton. So that's it for today for this lecture. If you have any doubts, drop us message in the comment section, and if you want online classes, we will provide link of academy in the comment section. Let us know. See you in the next lecture. Good luck.